Hey everyone, welcome back to another Turning Tuesday video. As always, I'm Phil Brown with JitCAD Cam. Today we're going to go over the Xometry Lathe Test part. If you haven't caught my actual milling test part, go ahead and check out Milling Monday. I actually went ahead and did that just yesterday. So let's go ahead and jump into this. So the first thing I'm going to do is I've already uploaded my part. I'm switching from design to manufacture, and let's go ahead and create our setup. Now there's going to be a lot of different ways that you all can do this part. However, I'm going to run you through a couple of simple ways to determine what's going to be best for you. So what I'm going to do here is we're going to go ahead and switch to turning and milling. My Z-axis actually automatically came through for me. I am going to start on this little bit of a longer tang of an end. To me, I think this is going to be a little easier to accomplish this first, and then decide what we're going to do when it comes to this center hub rolling area. So as you can see, my Z-axis, like I said, is good. I need to go ahead and adjust my stock size. Now, depending on the size piece of stock they provide you, of course, you're going to set that up here. I'm going to leave this pretty default. I do have a cheat sheet over here for a lot of these dimensions as we get into this, but overall, you can see everything came through as such. So there is no call out on here for threads at a quick glance. There is some chamfers and things of that nature, but they've actually modeled those in for us, allowing us to keep those edge breaks in. So the first thing I always like to do is to go in and face my part. So let's go ahead and face. Now, I am going to use a lot of default tooling here. So I'm going to go for a simple CNMT right-handed tool. As you can see, I can adjust my speeds and feeds, edit this down here, and add individual speeds and feeds based off what I want. But as you're seeing here, Fusion 360 is automatically picking up on where the front of my part is based on that Z-axis orientation. And it's also recognizing that based on the front of the model, the outside of my stock, as you can see here, going all the way to my stock inside diameter, and even moving out here to say, we want to go outside in. And for precautionary reasons, I always like to turn on multiple steps and let the software calculate that for me. So depending on how much material I have on the face here, will actually automatically calculate my step over. So let's go ahead and hit OK. So from here, let's go ahead and start to do our different profiles. Now, I'm going to attack this in a couple of sections here, which will look a little different than what most of you might do, but I haven't quite decided if I'm going to try to turn this whole profile here, or if I'm going to turn this first section, then hold on to this maybe a little different way. Maybe I'm actually holding on to this whole outside kind of hub-shaped profile, and then just doing the one end, maybe doing the second end, then doing the hub itself. There's a lot of different ways for us to do this part. So what I'm going to do is I'm going to go in and I'm going to do my turning profile rough. From here, I'm going to go ahead and define my geometry. And as I kind of just declared to all of you, we're going to go ahead and actually say it's not model back. We want to go to a selected face, which is this guy right here. Again, I'm going to jump over to my passes area. We do want to set our maximum depth of cut. Again, I'm just going to go with a simple 40, and I'm going to hit OK. And as you're going to see now, we're coming in and we're actually turning that profile and getting everything cut out and roughed out. So let's go back and do a finishing cycle. This time, I'm actually going to right-click my toolpath, and I'm going to derive. And this derive is going to allow me to shoot straight down to a finished profile. Again, the nice thing here is it's already kept, my back profile in contact. If I was making multiple passes, that as well would be there. Now, one thing that we are noticing, and if you guys didn't know, I'm going to turn on my in-process stock so we can get a glance at this, is it is going to be a little tricky to see, but you notice how my roughing cycle went past, but now my finishing cycle is actually stopping short based on what we're doing here. So I do want that finishing cycle to possibly come out further. I would also like to actually stop that roughing cycle instead of cutting that chamfer. We want to keep that near and close. So let's go ahead and go back and edit. And what I'm going to do now is I'm going to go to my geometry tab. And now what you're going to notice, there's what's called a contact point tool limit. Now, what's happening there is that is the actual point where the radius of the tool is touching. And that's why we're getting that kind of dog leg motion up over the chamfer. Now, if I wanted to, I could say cutting edge, and when I hit OK, you're going to notice that it's actually going to stop short. And what I did there, guys, I'm actually going to undo that. We all make mistakes, right? I accidentally changed the wrong one, so let's go to our roughing cycle. Again, we have that dog leg kind of happening and going up and around that chamfer. I'm going to go ahead and say cutting edge. And now, as you're seeing, we're coming down and we're stopping short and then running up the face of this part. So again, this is something that you may want to adjust based off what you're doing, to be able to actually stop it where you want it to stop and not let it go past that actual physical face. Now, again, based on our actual turning finish, I'm going to go ahead and go over to linking. And one thing I'm going to do is I could do a radial extension. And another thing I can actually do is I can allow it to cut the stock also. And what that's going to do is that's going to actually bring our facing profile up and straight out of our part. Again, cutting that nice clean move all the way up so that we're not actually stopping in the middle of a cut or causing any problems or have any weird overhang with what we're working on. Now, as you can see, that went relatively quick to cut that initial profile and rough it out. Now, if I wanted to, based on this profile, I could actually come in if I had a sub spindle. And let's go through this real quick. I'm going to go ahead and tell the sub spindle to come in. And what I want to do is I actually want to grab it at a certain location. So I'm going to take this back profile and drag it. Now, let's say I want to come in and grab onto this right here. So just like that, I was able to come in and do a sub spindle grab. Now, let's say we actually want to come in and do some of this more roughing profile in here. So again, I can kind of rinse and repeat what we've done. So we're going to say turning profile rough. I'm going to go ahead and turn on rest machining this time. Again, I'm going to do a selected point where we want to machine to. We want to machine all the way to that back face now this time. And for this one, I'm actually going to do a little bit of an extension. So you have what's called an offset here. So if I wanted to offset that, I could actually click and drag that back to get an idea that I want to go negative a certain amount. But what I'm really aiming to do is to get past that back face as much as I can. So again, we could go set our passes depth. And this time, let's just say we're going to do 50. And now, as you're going to see, we're going to have what's called waterfalling or undercutting starting to happen. Again, because of the relief on the backside of our tool, we're getting down inside this hub area. You may or may not want that at the end of the day. And now the key element is I don't want that. I prefer to avoid that because I'm going to come in with kind of like a lollipop or a dog bone to do this hub section. So what I'm going to do is I'm going to go back to my path. I'm going to go over here to my passes tab, and I am going to turn off the grooving option. And now what you're going to notice is we're going to just shoot straight across that upper profile, again, continuing straight down to the back and out as we did before. Now, if I wanted to, again, we could go a little further down, again, do our derive operation. I'm going to do a turning profile finish here. And now with that being said, all of my information has all come through. However, again, remembering I want to allow it to radial extend and to cut that stock. And now, again, you're seeing a little bit of a different concept here where we get to the back and wrap it out. The reason for that is because when we actually set our linking here, when you do a radial extension, sometimes it actually interferes versus cause the actual outcome you want. So again, as now you're saying the lead can cut that, that's not the case. What I want to go back again and now flip those two. So again, we're going to go ahead and say radial extension versus allow the lead to cut stock. And again, we're coming out and we're just retracting off our part. So a third way you guys could get away with this if you wanted is you could actually come in and we could set this based off the fact that I want to change my offset here. Again, a lot of different ways you could do this. Actually, we want to go 050 and we just want to get a little bit past that actual edge in the back and then come off nice and clean. Again, we may flip this part and grab it from the other end. There's a lot of things we could do with this. So let's get into grooving this hub. So what I'm going to do for grooving the hub, I'm actually going to go in and I'm going to attempt to do this with an actual groove toolpath. Now, again, we're going to attempt this a couple of different ways, guys. So go ahead and see what we can do. So we're actually going to do outside grooving, front to back looks good. I'm going to go pick my grooving tool. Again, Fusion's default library is really good to have all these different tools in here. So we're going to say turn and groove. And then what I'm going to do is I'm going to make sure that we're grabbing what is, I like to say, either a dog bone or kind of that lollipop cutter profile. And the lollipop is just kind of like a circle disc. So let's select that. Again, we do have the ability to use our rest machining. I am going to set a back area. Again, using that face. I do not need to extend it this time for no reason because, again, we're just going to stop there. We're only concerned about the inside area. And then we're going to go over to our passes tab. Again, you guys have the ability to set your step over to whatever you want. Again, full step downs, things of that nature. But what we're really looking at is the actual profile of going in and grooving this all out and then making our finishing pass to clean this up. Now, again, there's a lot of ways you could do that. This is the first way that you could just attempt this with kind of a traditional mentality. Now, I would like to do this based on a turning profile roughing strategy using that grooving tool. Again, I'm going to go ahead and kick on rest machining. I'm going to set a maximum step down here again. Let's just keep with the standard of 50 thou. And now what's going to happen is we are going to get a little bit of an error here, and that error is caused because, one, I failed to set my back profile, but also it's because of rest machining. Now we're starting to see tool paths overlap. So again, I just moved that up one and I generated it. And now you can see we're actually doing a left and right strategy for grooving this out versus an up and down vertical strategy. Again, if I go into this tool path, we set that back selection here. We're going to go ahead and say this is my back. And now you're going to see that tool path kind of only stays confined within that area. We are going past that again a little bit, guys. It happens. Maybe I just moved my profile edge. Again, instead of that back face, let's say I just say the top of that radius. And just like that, we've actually fixed that. So keep in mind, though, if I expand this out with that OD grooving toolpath, actually, I'm using the OD grooving toolpath with a roughing strategy. I do need to finish this up with a finish profile. So again, we go in, we say our finish profile, and from there, we're going to go ahead and let this thing do what it does best, but I need to reorder this again just because the actual groove cycle that you have here has both a rough and a finish in it. And again, that's interfering with what we're doing. So let's go ahead and clear this toolpath. So if you guys didn't know, we could go in and we can actually tell it to clear everything out. And then from there, I'm going to suppress it for now. And that just lets me know, that this toolpath is not actually needed. This way, I don't have to worry about where it is in the ordering. It's not going to affect what we do. So again, this is kind of a left and right. Again, we come back with a finished profile after the fact. Our initial grooving toolpath that we did have outside of that, this guy here actually did it as vertical passes. But now let's look at a couple other toolpaths that Fusion has. So we actually have what's called adaptive roughing. So the difference between the adaptive roughing and the normal roughing, as you're going to see here. So this time I'm actually going to set these boundaries a little different because we're going to force this to kind of stay within a certain limit. So let's actually use edge to edge. And then on our OD, we're actually going to use a selection here as well, which is going to be our model. And now what you're going to see is we're making a night and day different kind of move here. So if you're used to Fusion 360 milling, you're going to know that adaptive tends to be very archy, where in a traditional roughing or pocket clearing tends to be very straight line and square. So again, based on your machine and what you can get away with, this might be the best approach to only use one axis at a time, right? So we come in a little bit on XY or XZ, I should say, then we run in Z. Now, again, the adaptive roughing strategy here, you notice, we're actually doing a lot of X and Z simultaneous, and that's giving us a night and day different kind of chip load and the way that tool's going to react when we're actually cutting out those profiles. Again, to each their own. You guys can test them both out and tell me which one you like better in the comment section down below. I'd love to hear your feedback. Me personally, I do like the adaptive roughing very well here. But either way, you would still have to chase this guy down with the finishing cycle. Again, this is a roughing strategy as well as our profile roughing versus when we were doing grooving, which accommodated both. So now that we've kind of chased that all the way down, again, we've gotten to the point where we have this outer edge on both sides. Everything's a finished profile, as you can see. What I'm going to do is I'm now going to create a second setup, and we're just basically going to hold on to this outside section. I could also, if you guys didn't know, I could come in right now and I could do like a subspindle return. And actually, let's go run through that real quick. So I'm going to show you a couple of tricks. So let's do our subspindle return. What we're going to do is we're going to unclamp our primary now, and we're just going to return that guy back to our where we're working with. Now, one thing to remember is when you do a subspindle grab in any of your operations that you're kind of working with, you don't want your tool to start back here because odds are you're going to hit your subspindle. So you do want to go in these tool paths real quick, and you want to say, I want to go from the first point, and I want to go to the last point of my tool path. And what that is going to change is basically you're now going to wrap it over and then come into this point and then do whenever you're working. Same with wrapping out kind of in that X direction and then going back in Z to do your tool changes of that. This is the number one thing a lot of people miss. Again, looking at that, if we tried to wrap it to this position, we're going to hit our subspindle. So I just go into my tool path and I say, I want to go to a first tool path point, last tool path point, and now we're actually going to wrap it down basically in X and then get down to where we need to be to work with. Again, avoiding our subspindle. Another really neat trick here as we're looking at this is if you guys wanted to edit these all in one shot, you could actually hold the shift key or control and select the toolpath. Then you could actually type in something like safe, and then you could actually go in and override all of these in one shot. So you could see I haven't changed all of these, but some of them say first tool point, some still say safe Z. Again, if I say first tool point, in real time, you're seeing that blue highlight to show that this tool path is going to change. When I hit OK, I get notification that it's going to change that path. And now over here, as soon as I regenerate, of course, it's going to regenerate that tool path with the new profile defined. So now we did our subspindle return. Again, up to all of you if you don't want to use a subspindle. If you were going to hand flip this part, that's more than okay. So what I'm going to do now is I am actually going to go in and I'm going to create a brand new setup. And in my case, this is going to be the only difference. If you're using a subspindle, you're going to say secondary subspindle, or secondary spindle, I should say. Now, if you're not using a secondary spindle, you'll leave it on primary. But the key element here is we actually want Z the other way. So we're going to go ahead and flip our Z axis. Now, from a stock standpoint, you're going to see from preceding setup, and we're going to turn on continuous rest machining. And the reason why we're going to do that, as you're going to see here, with that setup 2 activated, that hat and everything that's still left to be machined came through automatically for me. So again, a ton of value with being able to actually bring that model through continuous, so you know what you still have left and what you don't have left. So let's go ahead and do what we need to do. Again, I was working with a secondary spindle. I'm going to change my secondary spindle. Again, just a little easier for me mentally. But now let's go in and basically repeat what we did. Now it's up to you. I like to do the old copy and paste move. So I just highlighted that toolpath, Control C, Control V. Now I'm going to regenerate this. And as you're going to see, it's going to come through on this backside. This could get you in trouble though. Now, if I go ahead and grab this guy here and Control C, Control V and regenerate, notice how it's still referencing that face that we kind of define things off of. So there is going to be times when you create profiles from scratch and it runs much faster than trying to copy and paste. Now, keep in mind, I don't have actual rest machining turned on here. So if we say rest machining, and now what you're going to notice is the rest machining automatically picked up on that weird kind of hat profile that we were working with. So again, just by toggling very simple options, we can, as I like to say, rinse and repeat a lot of what we have here. So another neat thing here for you guys is if you wanted to, you could actually say instead of horizontal passes, we're going to do vertical passes. And now we're actually vertically coming in and facing off that shoulder to get that actual profile for turning. Again, as you guys may guess or not, we could go ahead and derive turning. We're going to go ahead and do our finish cut. From here, we have our finishing cut now profiled in. Come in, clean up that actual chamfer, turn that OD profile, and just like that, we have completed everything and anything that we need for this lathe part. So let's run it through a simulation now. So let's go ahead and simulate the first op. Make sure we don't have any collisions. I'm going to go ahead and look at it straight on. This is going to run very, very quick. But as you can see, if I turn my model off, what I'm looking for is anywhere that there's still material left. So my tool nose radius and everything looks good. I don't have any red material anywhere. None of my tools crashed down here in my bottom timeline. So op 1 is looking amazing. So let's go to op 2. So what I'm going to do is I'm going to kick that model back on. We now have op 2. Let's go ahead and say simulate with machine. I'm going to go ahead and spin this around so that we can look at this from this side now. And again, we go ahead and hit play and no collisions, no issues whatsoever. So the only thing I really have to do now is 1, make sure all my tools are in the machine, but 2, go ahead and post this stuff out. So again, as I can just right click post process, define my post processor. From here, go ahead and actually post out to my machine. So let's see, do I have a post for a lathe in here? I do actually. So in this case, this is a Mazak post. Again, I can set my options based on my machine. Go ahead and hit my post process. And as you're going to see here, my file is going to open up with an error. And that's because I don't have a secondary spindle on this machine. So again, the post processors have a tendency to also be able to control what you do and do not have. So if you guys need post-processor edits, as always, this is a great time to let you know, it's not what you know, it's who you know. And we at JIT CAD CAM are here to make those changes to your post and add those features as you need. Now, if you want more information on that, feel free to use the link down below to reach out to me directly. and I will give you an estimate on what it's going to take. A lot of post-processor edits are actually surprisingly free if you are our current customer or have one of our advanced support packages. We like to call it the top tier support. That being said, is we also do ground up custom builds if you have something extremely one-off, as well as doing your actual machine sim model builds as well. So with that, you guys have a great rest of your day. I hope you like this Turning Tuesday. Get back at the day and get the day done.